Week 2, Lesson 4, Static Failure of Brittle Materials. We leave buckling behind and open the failure theories. A ductile part yields and deforms. A brittle part just breaks. A sudden fracture on the plane carrying the largest normal stress. 3 ideas run the lesson. Brittle materials fail on the maximum principal stress. They have different strengths in tension and compression, so you run 2 separate checks. And the principal stresses come straight from Moore's circle, including the out-of-plane zero you must not forget. Here's the problem. A gray cast iron part with 2 very different strengths, strong in compression, much weaker in tension, carries a plane stress state with a tension in X, a compression in Y, and a shear. Find the ordered principal stresses, the factor of safety in tension and in compression, and decide which one governs. The twist this lesson: 1 stress state, 2 separate strength checks. Concept 1. Brittle parts fracture. They don't yield. A ductile material stretches into a yield plateau and necks down before it breaks. A brittle material snaps almost immediately, a clean fracture on the plane of the largest normal stress. 2 features drive everything downstream. Failure is set by the principal normal stress, not shear, and brittle materials are asymmetric, much stronger in compression than in tension. That asymmetry is why 1 stress state needs 2 checks. Concept 2. The maximum normal stress theory, straight from the handbook. Order the 3 principal stresses largest to smallest. Failure happens the moment the largest principal reaches the tensile strength, or the smallest principal drops to minus the compressive strength. 2 inequalities, and the part must clear both. Turn each into a margin. The tensile factor is tensile strength over the largest principal. The compressive factor is compressive strength over the magnitude of the smallest. The smaller of the 2 governs. Concept 3. Where the principles come from. Moore's circle from Lesson 7 gives the 2 in-plane principles. Build the center and radius, then add and subtract the radius. But plane stress hides a 3rd principle. The out-of-plane face carries no stress, so 0 is itself a principal stress, and it must join the other 2 in the ordering. On the circle, the 2 in-plane values straddle the axis, and the out-of-plane 0 sits between them. Setup and the order is the lesson. First, Moore gives the 2 in-plane principles. Second, add the out-of-plane 0 and order all 3. Third and fourth, run the tension check against the tensile strength and the compression check against the compressive strength. Fifth, the smaller factor governs. The table holds the 3 stresses and the 2 strengths. The center and radius are the only computations before the checks. Solve. Part 1. The principal stresses. Center is the average of the 2 normal stresses. Radius is the radical from Lesson 7. Add and subtract the radius for the 2 in-plane principles. Now fold in the out-of-plane 0 and order all 3. The tension on top, the 0 in the middle, the compression at the bottom. The largest and the most negative are the 2 the theory checks. Solve. Part 2. The 2 checks. Compare the largest principal against the tensile strength. Comfortably below, giving a tensile factor of about 3. Compare the smallest principal against minus the compressive strength. Nowhere close, giving a compressive factor of about 15. Both inequalities clear, so the part is safe. The 2 margins are far apart because the compressive strength is so much larger than the tensile. The answers. Principles 68, 0, and minus 48. Tensile factor about 3, compressive factor about 15. The smaller governs, so the part is limited by tensile fracture with a factor of safety just under 3. Safe. Report the governing factor, not the loose one. Quoting the compressive margin would badly overstate how much room the part really has. Traps. 4 ways the brittle check bites. 1. Forgetting the out-of-plane 0. In plane stress, it is always a principal, and depending on the signs, it can be the largest, the middle, or the smallest, so order all 3 every time. 2. Reaching for yield strength. Brittle theory uses the ultimate strengths, and a given yield strength is pointing you at a ductile theory instead. 3. Running only 1 check. Tension and compression strengths differ, so the 2 checks are separate, and the smaller factor governs. 4. Checking shear. The criterion is on the principal normal stress, not the maximum shear. Quick recall. The principal stresses come from more, center plus or minus radius. Add the out-of-plane zero and order all three. Failure occurs when the largest principal reaches the tensile strength or the smallest drops to minus the compressive strength. Turn each into a factor and let the smaller govern. Golden rule: keep the zero in the ordering, run both checks, and trust the smaller factor. Next up, Lesson 5, Static Failure of Ductile Materials. That opens the pair. Today, brittle materials fractured on the maximum principal stress and used two different ultimate strengths. Ductile materials yield instead, and shear drives the failure. Lesson 5 covers the two ductile theories: maximum shear stress, or Tresca, and distortion energy, or von Mises, both key to a single yield strength, and both built on the very principal stresses you just found. Everything's at peprepengine.com. Cheat sheet, worked solution, and a quiz attached here.